Welcome everyone. In this video, we are going to see about Gauss elimination method. Okay, so it is a systematic approach to solve a set of linear equations. So we will be having a set of linear equations and we will try to find out the solution for that system. So first of all, what we need to do, we need to transform the system into an equivalent upper triangular or row echelon form using row operations. What do you mean by upper triangular matrix? You can say that the upper part will the upper part of the matrix will be having values and the lower part will be having mostly zeros. Okay, and then we will apply back substitution method to find out the unknown variables. Now let us explain this part with the help of one example. Okay, so let's see this example. So this is the system of or set of linear equations that we have. Now we need to find out the values of x, y and z. So first we will write down the augmented matrix. Augmented matrix means the values for x, that is 2, 4, 6 in first column, values of y 3, 7, 18 in second column, values of z in third column, and these values in the last column. Okay, so this is our augmented matrix. Now our aim is to make it a upper triangular matrix, that is this part will be having values and the part below the diagonal will be having, if we consider this as the square matrix. Okay, so till this part we will be having some values and these we need to make 0. So this is our aim. So there are not any fixed way in which you need to make these zeros. You can adopt any way you want. So I'll show you one of the ways in which we can do. So first we will try to make this particular element 1. So how we can do it? We can do it by dividing this row 1 by 2. So if I divide this by 2, that is the first element, we will get 1 here, and the remaining elements, that is 3 divided by 2, 1.5, 1 divided by 2.5 and 9 divided by 2, 4.5. The remaining values are as it is. Now we will try to make this value 0. So how we can make this value 0? If we see the next slide, we can make this value 0 by making R2 equal to R2 minus 4 R1. R2 equal to R2 minus 4 R1, that is 4 minus 4 into R1. So this will become 0. This one will become what? 7 minus 4 into 1.5. So whatever value is there, you will write here. So we are not bothered about the remaining elements. We just need to make this element 0. So that one we did by writing R2 equal to R2 minus 4 R1. Now similarly we need to make the down element also 0, that is 6. So how we can make it? We can make it by R3 equal to R3 minus 6 R1, right? R3 equal to R3 minus 6. So if we 6 minus 6 into 1, we will get 0 here. Similarly, the other elements will be reflected. So if we see, this is the matrix we got after performing these two row operations. Okay, so now we have made these two values 0. Now we need to make this element 0. So how we can make it? We can make it by R3 equal to R3 minus 9 R2. So if that is 9 minus 9 into R2, we will get 0 here, and similarly the other elements will be changed. Now this is our upper triangular matrix that we have got. Okay, that is the elements above the diagonal. From diagonal till here it is having values, and below the diagonal elements are 0. Now we will apply back substitution method to find out the values. Now if we put this one, so we will try to solve from this one, last equation. So it will be what? Minus 7z equal to minus 3. So from here we got the value of z. Now substitute the value of z in the second equation. What is the second equation? Y plus z equal to 2. So in place of z you put this value. So we got the value of y. Now we have both z and y value. So we can simply put it in the first equation to get the value of x. So this is the value of x. So this is how we can solve a set of linear equations using Gauss elimination method. Now we will see how to write C++ program for this method. So this is our C++ program. So I will explain it step by step. So first I have included the header files that I'll be using, IOStream, IO manip just to manipulate the input output, then CMAT because we'll be using some mathematical function. And here I have written hash define n3. Why I am giving n3? Because there are total three equations, right? Three values x, y, z we need to find. And here what does it mean? It means that whenever in the program we will see this variable n, its value is going to be 3. It is not going to be changed. Then using namespace std. Okay, now inside main I have declared the two-dimensional array. The name I have given as matrix, and it stands for, since there are, if you see the system of equations also, suppose let us consider we are trying to solve this one. So when we convert it into a matrix form, how many rows are there? 3 rows are there and total 4 columns are there. So same thing I have written here. So 3 in place of n, it will be 3 and 4 columns. So this is a 3 by 4 matrix. And then another array, one-dimensional array, I am declaring x of 3. This is for the this array is going to store the results that we will get, that is the values of x, y, and z. Then apart from that, we are using variables float temp s, then int I, j, k, just to because for the for loop, since it is a matrix, so we will be using for loops. So for that I am using these variables int I, j, and k. Then I'm going to enter the elements. So let's keep it. So enter the elements of 3 rows and 4 columns. Okay, so this one we will just strike it off. So here, that is, I'll be entering the values for the 3 by 4 matrix. So this for loop is for the number of rows, that is 3 rows. Then this next for loop is for the number of columns, right? So here I am giving for j equal to 0, that is 4 columns. And then I am entering the values in the two-dimensional array matrix ij. You know how to enter the elements, right? So we have entered the elements. So you see, so this is the for the set of equations I have written this augmented matrix. So what are the values? It was 2, 3, 1, 9, 4, 7, 3. So 2x 3y plus z equal to 9, 4x plus 7y plus 3 equal to 20. Like that I have written all the 3 equations. Okay, now according to this chunk of code, for j equal to 0, here we are trying to find out the upper triangular matrix. So for j equal to 0, j less than n minus 1. So j equal to 0, j less than n minus 1 means 2. We are entering, this is true, so we are entering the loop. For I equal to j plus 1, so I equal to 0 plus 1, that is 1, I less than n is 3. Again it is true, so we are going to enter the loop. Here we are trying to find by what value we want to find this value, by what value we should multiply with this in order to get 4. So this is true, so we are entering here. So temp is equal to, temp is the value, okay, that value, particular value, mat of ij. Mat of ij means what? Mat of 0 and mat of I is 1 and j is 0. Mat of 1, 0. So mat of 1, 0 means what? 0, if we start the index, this is 0, 1, 2, 3. Here also 0, 1, 2. So mat of 1, 0 is which value? Row 1 is this one because this is row 0. Row 1, column 0. So this is the value 4. That's why we have written 4 divided by mat of jj. Mat of jj means what? Mat of 0, 0. Mat of 0, 0 means 2. So 4 divided by 2 equal to 2. So we have got the temporary variable. Okay, clear? Now after getting the temporary variable, we are going to go into another loop. For k equal to 0, 0 less than n plus 1 means 4. K equal to 0, 0 is less than 4, so we are entering the loop. Here what we are going to do, mat of ik is equal to, so what is mat of ik? 1, 0. So mat of 1, ik means I value is 1 and k value is 0. So what is mat of 1k? So it is row 1, column 0. So this is 4. So 4 minus mat of jj. Mat of jj means mat of what is the value of j? 0. Mat of 0 0 is 2. So 2 into temp value. Temp value is how much we got? It is 2. So 2. So 4 minus 2 into 2 we got 0. So we have got this value is equal to 0. Okay. Now this part. Now see, we will continue this k loop till this condition becomes false. So now the value of k will be 1. So 1 is less than 4. So again we are entering. So what will be the new mat of 1 1? Mat of I value is still 1. So mat of 1, k value is 1. Mat of 1 1 means this value 7. So 7 is equal to 7 minus mat of 0 1. Mat of 0 1 means row 0 1 column 3. 3 into 2. So 3 into 2 is 6. 7 minus 6 is 1. So like that we are going to do for all these values. Ultimately we are getting this. So after this, next we are going to go to the next row. Okay. So this row is over. Okay. So next you see. So we have done for the row this one, right? Now we are going to work on this particular row. So for that, if you see, we are in now. This part is over, this loop is over, k loop is over. So once it is over, we will increment the value of I. Now what is the new value of I? Earlier it was I equal to 1. Now it will become I equal to 2. 2 is less than 3. So you see 2 is less than 3. So we are going to enter the loop. Again we need to find, that is for this, we need to, our aim is to make this particular 6. If you see this value 6, our aim is to make this 6 0. Right? So how can you make this particular 6 0? First we need to find by what number we should multiply this so that both numbers become equal. So for that we are going to find out the temporary variable. So how we are going to find out the temporary variable? By using this mat ij divided by mat jj. So what is mat jj? J value is how much? J value, if you see, J value is still 0. We are not incrementing J, right? We are still inside this particular. We are still in J equal to 0 loop only. So J mat 0, if you see, what is that? Temp is equal to mat ij. So what is mat ij? Mat, what is the value of I? 2. J value is still 0 divided by mat jj, 0 0. So what is 2 0 out here? So 2 0 is row 2 column 0, 6. So we are writing here 6 divided by mat 0 0. Mat 0 0 is this, row 0 column 0, 2. So we are writing it 2. So what is the value? 3. So temp value we got 3. Now we will again go to this one, right? For k equal to 0, k less than n plus 1. But first of all, k was earlier how much? We started with 0. So now what will be the, but still we are going to go from the beginning only. Okay, so k equal to 0, k plus k n plus 1. K equal to 0, k n plus 1 means 4. So here what we need to do? Here we need to do mat ik equal to mat ik. Mat ik means I value is 2, k value is, we are starting with 0. So mat 2k equal to mat ik minus mat of ik. Mat of ik. I value is how much? I value is now, here it is 2, not 0, mat is 2. To mat 2 into, one second, mat I, you see mat, sorry, mat jk, not ik, mat jk, sorry, it is 0 only. Mat jk, so what is mat jk? J is 0, k value is 0. So mat 0 0 into temp, temp value is 3. So what is mat of 2 0? So if you see mat of 2 0 is this one, this value, right? Let me focus properly. So this value. So this value is how much? 6. So we are writing here 6. Then mat of 0 0 we know it is 2. So we are writing it 2 into 10. So ultimately we got 0 here, right? So as I have explained this part, similarly we will go to now k equal to 1. 1 is less than 4. So mat of ik means 2 1. So again this same thing. So after performing these things, what values we got? The same loop that I have explained. So here we got 9, here we got 2, and here we got 15. Okay, so these things done. So now Next we will see what we need to do. So after the end of this, so we have completed this particular row. Okay, now after the end of this row, that is we have completed this one. Okay, now we will go to increment the value of I. What was the value of I? I was 1, so now it will become 2. 2 is less than 3, so we will again enter this loop. Now we will try to find out temp equal to mat of ij divided by mat of jj. Okay, so if we see here, come here. So now I equal to 2, 2 is less than 3, so we are entered in the loop. So temp equal to mat of ij. What is I? 2. What is the value of j? J is 1, right? We have incremented j just now. So mat of 2 1. What is mat of 2 1? Mat of 2 1 is row 2 column 1 9. Okay, and divided of mat of jj. So what is mat of jj? J is 1. So mat of 1 1. So what is the value of mat of 1 1? Row 1 column 1 1, right? So if you divide this by this, what you are getting? You are getting the temp value as 9. So after the end of this, so we have completed this particular row. Okay, now after the end of this row, that is we have completed this one. Okay, now we will go to increment the value of I. What was the value of I? I was 1, so now it will become 2. 2 is less than 3, so we will again enter this loop. Now we will try to find out temp equal to mat of ij divided by mat of jj. Okay, so if we see here, come here. So now I equal to 2, 2 is less than 3, so we are entered in the loop. So temp equal to mat of ij. What is I? 2. What is the value of j? J is 1, right? We have incremented j just now. So mat of 2 1. What is mat of 2 1? Mat of 2 1 is row 2 column 1 9. Okay, and divided of mat of jj. So what is mat of jj? J is 1. So mat of 1 1. So what is the value of mat of 1 1? Row 1 column 1 1, right? So if you divide this by this, what you are getting? You are getting the temp value as 9. So we have completed this loop. Now what we need to do? We need to increment the value of I. So what was the last value of I? If we see the last value of I, it was 2. So now it will become 3, right? Now when it became 3, so I equal to, see, we will have to start with this one, no? I equal to, I plus mean I equal to 3. So 3 is less than 3, no. So again we are going to come out of this loop also. Now what will be the new value of j? What was the last value of j? If we see, the last value of j was 1. So now it will become 2. 2 is less than 3 minus 1, 2. That is 2 is less than 2, no. So ultimately we are going to stop. So ultimately, after going through all this code, finally we have got this particular matrix, which you can see is a upper triangular matrix because all the values below the diagonal are 0. So in this part we have I have explained how we have created the upper triangular matrix. Now if you want to display it, you just display the value I equal to 0, I less than n, j equal to 0, j less than n plus 1, n number of rows and n plus 1 number of columns. The n value is 3 obviously. So we are just displaying the matrix. Okay, now we need to use back substitution method in order to find out the values of the unknown variables x, y and z. So this is the formula for that. So I will explain this part now. Okay, so this is our upper triangular matrix, and this is the back substitution method equation statements. Okay, so this is what I will explain now. So our aim is to find out the unknown values, that is x, y, the value of x, y and z, which will be present in the x one-dimensional array. The name of the array was x, where we will be storing the values of x1, x, y and z. Okay, so let's see how it is done. I equal to n minus 1. I equal to n minus 1 means 2. Now 2 is greater than equal to 0. So we are entering the loop. S equal to 0. Now we are going to do this one. Now see, after this no loop is given. It means that this particular line will keep executing till this condition becomes false. Now j equal to I plus 1. So j equal to I plus 1 means I value was 2. So now it becomes 3. J equal to I plus 1 is 3. Is 3 less than 3? No. So we are not going to execute this line. We will go to the next line. So x of 2. So x of 2, x of I means x of 2 is equal to mat of in. In means 2, 3 minus s value we got 0 divided by mat ii. Mat ii means I value is 2, so mat 2 2. So what is the value of mat 2 3? Row to column 3. So row to column 3 means this value minus 3 and minus 0, obviously we got minus 3 divided by mat of 2 2. So what is mat of 2 2? Row to column 2, it's minus 7. So ultimately 3 by 7. So what is present in x of 2? So in what is present in x of 2? X of 2 is x of 2, which represents the value of z, by the way, in our system of linear equation. So the value of z, we got it as 3 by 7. So after getting this value, it means we have completed loop 1. Now we will update the value of I. We need to decrement the value of I. So what we are getting, I was 2, so now it is 1. Now 1 is greater than equal to 0, true. So we are entering the loop. Again we are making s equal to 0. Now again we are going to start this loop. J equal to I plus 1. So I plus 1 means j equal to 2. Now 2 is less than 3, right? 2 is less than 3. So we are going to enter this loop. So what it is, s equal to s plus mat of ij. Ij means I is 1, j is 2 into x of j. Okay, what is x of j? X of j means j value is 2. Now simply put the values. What you are getting, s value is 0, mat of 1 2. Mat of 1 2 means row 1 and value 2, that is we are getting 1. Okay, into x of j, x of 2 we already got here, no? X of 2, it is 3 by 7. So if we do this, you are getting 3 by 7. S value is 3 by 7. Now we are going to go again. We will continue this these two lines till this condition becomes false. Now j equal to j plus plus means j becomes equals to, now it became 3. Now 3 is less than 3, no. So we will stop and we are going to go to the next line. What it is, x of I value is still 1. So x of 1 is equal to, simply put the values I and whatever it is. So mat of 1 3 minus s divided by mat of 1 1. So mat of 1 3 is how much? Mat of 1 3 is row 1 value 3, right? Column 3. So this value, so what it is 2 minus 3 by 7 divided by mat 1 1. Mat 1 1, you see, mat 1 1 is this value, mat 1 1, so divided by 1. So ultimately you are getting 11 by 7. x1 equal to 11 by 7 means, x1 means y value we are getting 11 by 7. Follow this same procedure. So after getting x of 1, finally we need to find out x of 0. So follow the same procedure loop like this in order to get the value of x. Okay, to get the value of x. So this is how this particular loop works. Now let's go back to the programming part. So now after this, since we have got the values of x, y, z, which is present in the one-dimensional array x, we just need to simply display the values. So we are going from I equal to 0, I less than n, and then simply we are going to display the I plus 1 means x of 1 will be x value, x of 2 will be y value, x of 3 will be z value. Okay, now if we run it, so enter the values, elements of 3 rows and 4 columns. So simply I am putting some values here. Okay, that's it. Now if I press enter, so this is the upper triangular matrix. You can do some data manipulation here to show it in a proper matrix form, and these are the solutions, x1 to 3. So that's all about Gauss elimination method. Thank you everyone.